are starting Mars with a true hero. Why? Because she didn't go to the party because she only got here last night. Hence why she has more energy than all of us. And she's truly great. Annie Talvasto. She is CNCF ambassador and product marketing manager. I hear she had a little workplace change, but she's going to tell you all about it herself. Here's a little bit of what I know about Annie. Annie is a cloud-native technology marketer, is an international technology speaker, hence why she's here, CNCF ambassador, and specialist in Kubernetes and cloud-native ecosystem. Again, please do let us know that you're here by sending your questions on Pine, and we will address them at the end of the session. And let's begin. Kubernetes cost optimization by Annie.
So yeah, welcome everyone. Super happy to be here talking to you about Kubernetes cost optimization. How to actually do it is the topic of today. Very excited. As mentioned, I am a Kubernetes and cloud native fan, so definitely excited for this. So let's dive right into it. So I usually try to begin all of my talks by kind of really briefly just discussing, okay, what will you learn? What are the goals? What are the what's the point of this session? Well, I think in this session, it's really clear. So it is to learn the best practices for cost optimization, and that's pretty much it. Very simple, very straightforward. I will have like literal step-by-step tips on how you can do it, but also a lot of vendor and open source project recommendations that you can use to kind of supercharge your cost optimization journey as well. So there was a nice intro to me already, but just continuing a bit from there. So as said, I'm Annie. It's nice to meet you all through this virtual conference lens. I'm a senior product marketing manager at Camunda, but I was working at CastAI until just I started at Camunda this Monday, and CastAI is a cost optimization company, and Camunda does process automation. So there has been a bit of a change, but at the same time, I'm still, again, super excited about these topics and still working with Kubernetes. I'm also a CNCF ambassador as well as an Azure MVP. And I'm also a Kubernetes and CNCF meetup co-organizer for over 4 years now, as well as I coach early stage startups. And then I'm also the co-host of Cloud Gossip podcast. So all in a nutshell, really just a fan of Kubernetes and cloud native ecosystem, definitely. So I think one of the most important things as far as cost optimization what to think about is why does it actually matter? Because I think in the past, cost optimization was not really truly a top priority for a lot of organizations. Well, to an extent, obviously, like every company, every organization has it on their mind, but particularly for the technical side of things. And I completely understand that. Obviously, if the world is so that you need to purchase physical servers in ahead of time, to estimate the demand. Obviously, you have to over-provision. You have to get more than what you maybe even estimate to have, because then you need to be ready if things hit a lot, and you need to have a lot of capacity really fast. But then nowadays, this cloud world has really made it possible that actually we can now meet the demand that's needed from our technical services in quite a lot more precise manner than we could in the past. So the advent of cloud computing and so forth has really led us to a situation where we can actually cost optimize really well, which is, I think, really great because it's also obviously not wasting cloud resources. And if a organization does cost optimization, the organization can, for example, spend more time and money and effort on things that are more important. So, for example, hiring new developers, doing anything that's, not just spending money on compute that's not being used. But that's essentially kind of it, in my opinion, at least. But every organization, every individual developer obviously has their own reasons why cost optimization matters for them. But then why is it, if it's so important and if it's so kind of nowadays particularly a topic that one can kind of achieve, why is it then so complex? Why is it hard to achieve? Why is it kind of difficult to get to? Well, That's true. It is very complex and it is hard to kind of grasp in the beginning, particularly, because this is a snapshot of AWS pricing actually. So this session I'm focusing on AWS and Azure, but a lot of these are for all clouds essentially. So there is a lot of different kind of CPU resources, compute resources. The billing gets really difficult. All of these things just add a lot of complexity, which is really hard to manage then. So it is definitely not easy. And, just from the basics of, how many nodes do you need and what the size should be, or how many pods or containers do you need and how big they should be and so forth. So it does get a bit tricky. So if you are sometimes overwhelmed by the topic, no worries, you're not alone. So just to kick us off, just a quick, super quick guide into how cloud pricing then works. So the on-demand instances is the type that's usually kind of, I think people, when they think about cloud, they might think about it. So it's the pay-as-you-go model, so you only pay for the resources that you actually use. So for example, AWS charges you for every hour of compute capacity by your team, but you don't face any long-term commitment and so forth. So it's purely like on-demand based pricing. Then you have reserved instances, plus also in addition to that, the savings plans in AWS. And in there, you buy capacity beforehand, upfront, and then you commit to using X amount of it. And these differ a bit within the cloud providers on what the kind of exact setup is and whatnot, but that's the basic idea. You reserve instances, you kind of commit to a certain amount, and then whether or not you end up using all of that amount, you still have to pay for all of the stuff that you have reserved. And then you have spot instances or spot VMs in Azure, which is then, it's a very cost-effective pricing model because you bid on resources, CSPs that aren't using at the moment, and you get to save up even up to 90% of the on-demand pricing. But it does come up with a bit of, people usually are afraid of using them. It might be a bit of a scary thing to approach because it comes with a limited availability. So the cloud provider can pull the plug with just, for example, 2-minute warning or a 30-second warning. So it kind of can feel a bit hectic at the same time. They are a great thing to use, but you do have to know what you're doing or use a tool that automates this on your behalf. So there's 2 options there. And then there is a dedicated host option, which is a physical server with an instance capacity that's exclusively for you. So this is usually used for particularly if you have, a lot of governance or these kind of needs and whatnot. So then our mini guide into the topic continues. So how to forecast cloud cost. So there is essentially 3 ways. So you can analyze your usage reports. So you need to achieve clear visibility of your cloud expenses. So you can monitor the resource usage reports regularly, and you can set up alerts and whatnot to actually keep your bill in check on that way. Then the second one is model your cloud expenses. So how do you calculate the total cost of ownership of your cloud resources? So you should start by analyzing the pricing models in a plan, capacity requirements over time to forecast cost actually. It's also smart to measure application or workload specific costs to develop an application level cost plan. And then you have detect peak resource usage scenarios. So you should use periodic analytics and run reports on your usage data to identify these scenarios. So you can use other data sources as well. So for example, if there's seasonal customer demand patterns, you can use all of these things to your advantage. All in all, if you start doing cost optimization and just kind of finding out about it, you will notice that there's a lot of things you can do, because essentially any best practice for DevOps or managing your resources very well is applicable to a certain extent to cost optimization, because if you are managing your resources very well, you are managing the cost very well. But this is just there's so many to go through. Not even this 45-minute session will have the time to cover exactly all of these. So I've kind of distilled it to 8 best practices for cost optimization. So let's get started on them. So first step is defining your requirements. So you have to know what you want to actually do. So you should only order what your workload needs across the compute dimensions. So CPU count and architecture, memory, storage, network. And an affordable instance might look tempting, but really what happens if you start running a memory-intensive application and you end up with performance issues? So you should pay attention when choosing between CPU and GPU dense instances for sure. The second one then is choose the right instance types. So there's a lot of instance types to choose from. That is, the biggest line item on your bill for sure. Compute resources. So just picking the right VM instance type can save you about 50% of your bill. And cloud providers do offer many different types of matching, right range of use cases. But you really have to know what you're then kind of picking if you want to take the most out of it. Cloud providers roll out different computers for their VMs, and the chips in those computers have different performance characteristics. So you might pick an instance type with a strong performance that you don't actually need in the end. So then you have kind of too much performance for what you need, and then you end up paying for it quite a lot. And then the third one is verify storage transfer limitations. So data storage is another cost optimization aspect that you can think about, and each application out there comes with a unique storage needs. So make sure that the VM you pick has the actual storage throughout what your workloads needs. So you should also avoid expensive drive options like premium SSD unless you're really planning to use them to your fullest. And then check if your workload is spot ready. So I have like 3 tips here for spot, because if you really want to get serious about cost optimization, you will more likely use spot instances or spot VMs, because that's one of the best ways to actually do it, other than just some other things. So the spot, I think 3 or 4 tips starts. So they are a great way to save on your Kubernetes bill. But then you have to answer the questions: how much time does your workload need to finish the job? Is it mission and time critical? Can it handle interruptions? Is it tightly coupled between the instance nodes? And what tools are you going to use to move your workload when cloud provider pulls the plug? So these are the questions that you have to think about before you start using spots. So then you should cherry pick them. So when you're choosing, then pick the slightly less popular instances, because they are less likely to get interrupted as well. So once you pick the instance, check its frequency of interruption. So this is the rate at which the instance reclaimed capacity during the trailing month. You can see it, for example, in different cloud advisors. So AWS Spot Instance Advisor helps you there, and Azure Advisor has some help there as well. But AWS Spot Instance Advisor, the name already kind of suggests it is made for this, so it helps you quite a lot there. So don't shy away from using spot instances on more important workloads. If you know what you're doing, it will work really lovely at the same time. So then you should bid your price on the spot. So the rule of thumb really is that to set the maximum price to the one that equals the on-demand price, because this is how you don't. So otherwise you will risk getting your workloads interrupted, and you might end up paying a lot more as well. So you can set up groups of spot instances, for example, in AWS Spot Fleets, and request multiple instance types at the same time as well. Yeah. And then use mixed instances, and this is a completely Kubernetes specific thing as well. So it's a really good one for this. So mixed instance strategy gets you a great availability and performance at a reasonable cost. So you basically pick different instance types, and some of them are cheaper and just kind of good enough, but might not be suitable for high throughput, low latency workloads. So depending on your workloads, you can often pick the cheapest machine and make it all work. Or you could have a smaller number of machines with higher specs. So this can help you slash your Kubernetes bill, because each node requires Kubernetes to be installed on it, and it adds always a little overhead. But mixed instances do have some scaling challenges. So in mixed instance scenario, each instance uses a different type of resource. And while you can scale up the instance in your auto-scaling groups using metrics like CPU and network utilization, you'll though get inconsistent metrics. Cluster autoscaler helps you here by allowing you to mix instance types in node group, and your instances must have the same capacity in terms of CPU and memory as well. last but not the least on this 8th best practice list, after that we're going to go to the demos as well as the examples of different products that you can use. So make multiple regions work for you. So instances spanning across several availability zones increase your availability. So you should then configure multiple node groups, scope each of them to a single availability zone, and then enable the balance similar node groups feature as well in AWS. And if you create only one node group, you can scope that to the node group to span across multiple availability zones. So these were the 8 best practices that you can just kind of follow. You could even follow along, I guess. But essentially, this is the list here, and then we're going to get to learn more about cost optimization. So what is actually then holding teams back? If we have all of these things I talked you through, obviously a simplified version, but still, we know how to forecast cloud cost, we know why it matters, we have the best practice tips and tricks list, then everyone could just, start implementing immediately as just, step-by-step guides. So what's actually the thing that's holding teams back, and our teams, our developer teams actually doing a lot of cost optimization. So FinOps Foundation, which is a foundation under Linux Foundation, really great one. So in there, they do this kind of state of FinOps report where they ask people who are obviously already interested in the FinOps topics. So they are probably relatively at least deep there, and they have been asked 2 questions, for example. So what challenges do FinOps teams actually then face? There's getting engineers to take action, dealing with shared cost, accurate forecasting, reducing waste or unused resources. So I think it's very, very interesting that, for example, the biggest issue that teams face is getting engineers to take action. So it is not that's not an exact technical challenge, like, as some of the others might be, but it is a culture, it is a kind of team dynamics challenge as well. So that's where then clear that, okay, we have all of these tips that one could use, and you could just go one step by step, but that's not a perfect solution to the issue, because the people might not be taking action, because these kind of manually doing all of this work takes quite a lot of time. So then if that's the situation, that the engineering aren't really taking action, and then what tools do they then use? Because tools could help lower the threshold to take action. So then you can actually get faster there. So in there we see that 26% use native tools, some percentage use the third-party vendor platforms, and 32% use spreadsheets. And I know that there's a lot of people who do love spreadsheets, a lot of Excel lovers, but at least for me, just a simple spreadsheet isn't maybe the best way to get me to take action out of like a lower threshold. So that's why I think there's a lot to do as far as vendor and tooling and automation, for example, that you can use actually to get to the next level from the kind of the manual tips and tricks. And that's actually here a point. So nearly half of the respondents say that they have a little to no automation. So this is, I think, to me at least, seems that, okay, the way to get people to take action and to kind of lower the threshold would be to use different tooling that can help you then get started there. And for today, I will be talking through a few of the CNCF project solutions. So CNCF is Cloud Native Computing Foundation. So it is the home for Kubernetes. So CNCF is an umbrella that has multiple open source projects underneath it. For example, Kubernetes, Prometheus, all of these things. And I'm going to give you a few examples of open source project solutions and that you can use to do cost optimization. And then at the end, I will also show you a few vendor options that you can use to kind of take a fully holistic approach as well. So we're gonna, here I have a list of then event-driven autoscaling to use KEDA, for example, application management Helm. You can use Prometheus for monitoring, and you can use container workflow for with Flux, and service mesh. There's LinkerD, Kuma, and Measure. If you have multiple service meshes in use, and then you need the service mesh management plane. But let's dive deep, relatively deep. It's not a KEDA deep dive session, but let's have a closer look at KEDA. So what is KEDA actually? So default Kubernetes scaling is not really well suited for event-driven applications. So Kubernetes is more for resource-based scaling, so CPU and memory. So in this so event-driven scale controlling can run inside any Kubernetes cluster. So KEDA is the fix here, because it can monitor the rate of the events to preemptively act before the CPU is even affected. So that's where the magic comes in. You can install it to new or existing clusters, and you can use extensible and pluggable scalers to grab metrics from multiple sources. So what are then kind of the KEDA principles? I'm going to have a KEDA demo to kind of showcase you actually like literally what happens if you start using KEDA. But the principles are not rebuild anything that Kubernetes offers out of the box. So it's a new solution on top of Kubernetes that you can use. It's single purpose, simple, and non-intrusive. So it's very easy to use and very easy to just plug in. And it works with any container and any workload. So, and I have a demo, which is KEDA demo scaling.NET Core Worker with Azure Service Bus. And here is a very abstract architectural kind of graph or image into how this demo app by the KEDA people looks like. And it just says, there's order portal, order processor, order queue, and so forth. But how you can imagine this demo application to be, it's essentially if you were to be running a web shop, selling food, clothes, whatever, and you have a high demand. So you have suddenly a lot of people want all of your produced products, services, everything at one time. So you need to actually scale up quite a lot, which is then obviously if you were to keep that high level of compute resources constantly, it would be very expensive. So auto scaling will help you there. So it's like a web shop, you can imagine. So we can actually jump into the demo now. Let's see, I have multiple terminals open, so let's pick the ones that we actually need for this. Maybe let's actually close this so we see better. Perfect. Let's get to the correct notes. There we go. Then just before we kind of get to the action on the demo, I'm gonna open up something so that we can actually see what's going to happen when the demo starts, because the demo itself is very fast. But to see what's happening, we need to open, for example, this, do kubectl get services to see the order queue length, so that when the orders start to come in, we can actually see what's going to happen. So here we have order queue length, order queue, number of messages. Then you will see the things happening in here. And to kind of get even more visibility, we're going to do kubectl get deployments to the blue one here. So in here we see how many order processors are ready at that moment, because we will needing a lot more than the 0 out of 0 that's at the moment. So then we do kubectl get bots to actually get to see into the history of what's happening as well. So in here we will then start seeing what's going to happen to the status of the order processors. And then now that we have all of these things set up here and we have more visibility into what's happening within our order queue, we will then actually do this .NET run project for KubeCon, since I did the same demo in KubeCon. So now it's asking, let's queue some orders. How many do you want? And we want 100 orders coming right up immediately. And then things are going to be starting happening. So there's a salad, bikes, sausages, chicken, bikes, so many things, And there we see the order queue spiking. We see it getting up. And then we should start seeing more action in these ones as well. But we see this going to reaching to 100 soon. Yes, they are taking action. You can see here that the containers are starting to, the order processors is going to container creating, it's going to pending, it's getting all those orders processors ready. And here we can see it's already at 4 out of 4. And here we can see that the order queue is peaked at 100. And now it's, we are getting all of those order processors so that we can actually process all of those orders with those order processors. So we can get to handling all of those. So now we see the queue going down. We see that in here we are going from pending and container creating to actually just running the order processors. And in here we see that, okay, we are at 8 out of 8. Oh, we are already at 10 out of 10 now, while I was saying 8 out of 8. So we got to the kind of max amount. And now the order queue has gone down already. It's at 0. So we are at 10 out of 10 order processors in use. We are simply just running them as well. So we there was a huge boom of orders. We needed to handle all of them very fast. So KEDA auto-scaled up, and now it will actually auto-scale down as well. So this is exactly what then the cost optimization also looks like. So instead of wasting resources, spending money when you don't need it, it will actually only get you going and take you all of the resources when you actually need them, so that you can meet the demand when it's happening. And eventually, in about 5 minutes, KEDA will start auto-scaling them down. And it's gonna just say, like terminating in here, the status will be terminating, and in here we will eventually get back to the 0 out of 0 as we had in the beginning. But as said, it's gonna take about 5 minutes, so we don't have to wait until that time to actually, when we can move on with this, move on with the presentation. Because even though the demo is great, we do not have to stare at it for 5 minutes. And it's actually really great for environmental reasons as well, because then you are also obviously using resources only when needed, so you're minimizing cloud waste as well. So, kicking off to the next CNCF project that I promised to talk about, so Helm. So Helm is package manager for Kubernetes, and whereas KEDA is an incubating CNCF project, so it's kind of halfway through the maturity. Helm is a very mature project, it's very well known, and it's package manager for Kubernetes. It's homebrew snack or chocolatey for Kubernetes, essentially. And the way that, for example, one Helm maintainer, I think, put it really well, Helm is package management, so it's tooling that enables someone who has knowledge of an application and a platform to package up an application so that someone else who has neither extensive knowledge of the application or the way that it needs to run on the platform, so that they can actually use it as well. And it's good for cost optimization, because obviously if you are managing your services, you're managing your different applications that you're using very well, you will not be wasting money as far as using the services goes as well. So what are then the benefits of Helm in here as well? So manage complexity. So charts describe even the most complex apps, provide repeatable application installation, and serve as a single point of authority. It has easy updates, so you can take the pain out of updates with in-place upgrades and custom hooks. And it has simple sharing, so charts are easy to version share and host on public or private servers, and you can use also Helm to roll back to an older version of a release with ease. And now just a few principles about Helm. So Helm takes security very seriously. As mentioned before, it's a very mature project, and it has multiple maintainers, multiple companies backing it. It has power user email list, release candidates, and so forth. It supports Mac, Linux, and Windows, and it passed 1 million downloads a month already in 2019. And Helm is used by using charts, and the prerequisites are just to have a Kubernetes cluster and deciding what security configurations to apply to your installation, if any, and then installing and configuring Helm. Then I have a quick Helm demo as well. So just to tell you how to easily deploy a complex application, in this case WordPress, to Kubernetes using a Helm chart. So let's get back to here and let's close this amazing list of orders from the KEDA one. And then let's get to my Helm notes then. So here we have, we have to switch the cluster first because these are in different ones. Just a bit of smoke and mirrors and it's just switching fast. There we go. So then we can get to this demo actually. So we do easy account show just to show you that I'm logged into Azure and everything is working great there. Once I did this and then I realized that I wasn't even on Wi-Fi in the conference and I was like, oh, whoopsie, need to join super fast. So if we do kubectl get services, we will see that we have an empty Kubernetes cluster in this one. That's empty for this purpose because I want to show you that everything is actually empty, so we are doing it from essentially scratch. So then just to further show that, we have Helm list, And there is no Helm releases either there. So now would be the moment that we would need to add the Bitnami to the Helm. So Helm repo add Bitnami. But for me, it already exists. So then it's skipping. But if you were doing it for the first time, this would do more things for you. So then we can do also Helm search repo in WordPress so that we can actually see what the WordPress releases available are. So we will be using the Bitnami WordPress that you can see there. And now we will actually get to the in like the installation part. So we do Helm install Bitnami WordPress generate name. And in here, after a while, it's going to start telling us what happened. So here, now we are actually generating that WordPress site. We're actually getting to that. So if we want to start whatever blog or something, now we're actually getting there. So now, like when I showed you before the kubectl get services, then it was an empty cluster. Now we can actually see, hopefully, if everything went well, it will not be. Yes, there we have an external IP already ready. The WordPress will not have sprung up yet because it takes a bit time, but no worries, we can just hop it there so that when it, we can hop it, wrong browser. We can just put it here so that when it will spring up, we can actually get to it. It's gonna load there a bit slowly. So while that's happening, we have actually things to do. So when we get the WordPress up and running, we don't want to just look at it and say, what a nice looking WordPress admin site. Woo, what a great thing that is. We want to actually get to we're using the WordPress and we actually want to get to have the username as well as the password to that. So for that, you can see actually here. So we have the echo username. So use user there, and to get the password, we can actually just copy paste this because it's stored as a Kubernetes secret. So then we're going to put this in, and then we get perfectly the password there. So when the WordPress springs up, we can actually just plug the username in, plug this password in, and we will be in, and we can start writing our blog. So all in all, like what has happened within this very short amount of time is that we've installed WordPress and MariaDB to our Kubernetes cluster, configured WordPress, and stored the admin credentials securely as Kubernetes secrets. And as you could see from the switch of color in here, we are in. We have our WordPress up and running. And if we want to get to now to the admin place, we go and write admin. And then we do user there. It's always telling me that. But then you put the password in and then we click login. And we should be on our merry way. Perfect. Now you see, I think it was rather short, really easy. Very, very easy to do with Helm. Perfect. So that we can start writing our amazing blog. Yeah, let's kick and off and move to the next CNCF open source project that you can use. So as mentioned before, service mesh is a really great way for cost management in Kubernetes as well. So LinkerD is a service mesh which is underneath the CNCF umbrella again. It is a graduated project, very recently graduated project. And it's actually the first service mesh as well. So it's an ultralight, ultra-fast, security-first service mesh for Kubernetes. And the overall goal of LinkerD is to reduce the mental overhead of having a service mesh. So it is similar to Istio, but Istio has a bit of more features and whatnot, but this is more maybe easier to start using it simply because less features, it's a bit lighter. And it provides you observability, reliability, as well as security. So it gives you service level important metrics as the success rate latencies, reliability retries, timeouts, as well as the security part. So then what are the kind of parts of LinkerD? So LinkerD has a really thriving open source community. So there's a lot of tutorials, a lot of material available. You can really kind of get used to using it really easily. It has a simple and minimalist design, so no complex APIs or configuration needed. So for most applications, LinkerD will just kind of work out of the box. It has deep runtime diagnostics, so you can get a comprehensive suite of diagnostic tools, including automatic service dependency maps and live traffic samples as well. And then, as mentioned before, it's light and fast, so it's built in Rust, and LinkerD's data plane proxies are very small and very fast. And it installs in seconds with zero configuration. And then it has actionable service metrics, as mentioned before, so the success rates, request volume, and latency for every service. So what are then the kind of principles? It just needs to work. It's ultralight. It's simple to reduce operational complexity, and it's security first. LinkerD has its own custom proxy. So Envoy is another CNCF project that quite a lot of Kubernetes-related cloud native use as a proxy, but LinkerD has its own just to make it more custom and secure as well. It has a very heavy focus on Kubernetes. So what is then needed to use LinkerD? This is it. So that's just injecting this. So it's very simple, very easy to get started there. And I do have a quick LinkerD demo as well. Then let's get to here. Let's get to that one. So to get us started on the demo, which is the LinkerD demo app, we need to first see what is the app that we will get all of those success metrics and all of these things out from. So then we can actually go to here. So this is how the app looks like that we will soon get the data from. So you see here, it's an emoji vote, so very exciting, very complex. It actually is a very nice architecture app. So we can vote here. We can vote with a crying face one or laughing crying face one. We can pick another one, so we can pick the mask one. We like that one, and then we can actually view the leaderboard. So in here we see that there's quite a lot more votes. In addition to the 2 votes that I just cast. So there is a lot of actually bots voting on the background as well. So I can actually open up a new terminal. I have so many demos in this presentation, so it gets to this point where I just have to like open up a new one here. Oh, it's kind of difficult. Let's open this one. There we go. And then if we do LinkerD and emoji vote top deploy, we will start seeing the bots voting in this one. So you can get quite a lot of data already by this. And then if we go and actually get a bit more graphical representation into what's happening, we need to open up another one. There we go. We're going to get to the LinkerD dashboard, and it's opening up in the browser that was not on the screen there. Perfect. But here it is. It opened this one here. So we get to this. So in here we see the emoji voter app, we see the success rate, we see the latency, we see all of these things. And if we want some of the same data that I just showed you there, we can go to, for example, here. We can pick the namespace, which is this one, the emoji voter again, because that is the app that we are looking at the moment. And then we click here, and then we see again more info there. And if we want even more kind of fancier looking graphics, we can go to the Grafana part of this, and then we're going to go to more Prometheus. So we see the global success rate, we see the volume, we see the deployments, we see a lot of data really easily. So that's like a mini demo into how LinkerD works and how does it look like to use it. So then, those were a bunch of open source projects that you can use to do cost optimization, and obviously there's others. There's Flux, there's whatnot. You can just learn more about them as well. That you can just kind of get kickstarted there. But there is obviously a lot of vendor solutions as well that you can use. I worked at CastAI, which is a great one for if you want to do, for example, using spot instances in an automatic fashion, where you just kind of put in, you give for just to get a report, you put in your read-only cluster rights, and then it will give you a report. Okay, these are instances that are spot ready. These are instances that you can use. This is the configuration that you have currently, and this is, and then there would be an example of what would be the optimal solution that you can use. So that is one way to kind of automate this, obviously, like very in an easy way. Stormforge as well as Spot.io offer similar solutions there as well, where you can then kind of, you get first the report and whatnot, for example, with Cast.ai, and then if you give more rights, you then will just kind of automatically, magically optimize everything, and you will get a lot of savings in one go. So there is kind of, you can use open source projects to do some of these things, or you can use the manual kind of, choosing all of these things manually yourself with the help of all the Spot instances and everything, or then you can use a vendor solution for like a very comprehensive solution to manage things. And then KubeCost, for example, is a really great tool for the visibility part. So it's really great for the reporting and just kind of understanding what's happening within your billing as well. So yeah, just kind of recap what has happened, and then I have some learn more resources coming up as well. So we have gone through why cost optimization matters. We have gone through 8 best practices that you could start using as is. We have gone through CNCF projects to leverage, and a closer look at a few of them. So we went through KEDA, Helm, as well as LinkerD. And then we learned some vendor solutions that you can use as well. And then we have some learn more resources that everyone can kind of jump onto as well. So FinOps Foundation, as I mentioned it before, is a really great place to start. So if that 8 best practice lists was not enough for you, there is a whole book on these topics that you can kind of, get super deep diving into how to do these things very nicely. And FinOps Foundation is working on really great frameworks and principles on how to do these things in a standardized way as well. I have an article with Kong, as well as all of the vendors have really great articles on how to reduce Kubernetes cost as well. Highly recommend those. If you are new or like newish, more beginner to these topics, you can, for example, use TechWorld. Nana has a Relegate Kubernetes content to learn through with. And my favorite place is always CNCF YouTube. I essentially live there. There's all of the sessions from KubeCons, for example, are added to CNCF YouTube channel. So I highly recommend checking that out, because you can see like a 30-minute to 45-minute deep dive on all of the projects that I talked about today in there. So you can kind of get there to learn even more. And then, as always, I will add the links and slides to my GitHub. There's like a presentation area there. So if you later today are like, damn it, I should have taken that one link or one thing to write it down or something, you can go there and find them from there. So no worries. But yeah, that's it from me. I hope everyone got something out of this.
Thank you, Annie. Let's give a round of applause. Who's still alive over here? There's some thank yous going on online, but no questions so far. Any questions in the audience here? I see. Well done. I recommend to ask, if you remember any questions that you would like to ask Annie, buy the cup of coffee, because we're going to have a little break today at the moment. And one more time, thank you very much, Annie.